In this video, we're going to be looking at topic 1.2, which is segment measures, distance, and midpoint. We're going to look at some vocab first. So our first vocab word is postulate or axiom. We typically use postulate in this class, but I'd like you to be familiar with axiom too, because some books do have it. And a postulate is a rule that is accepted without proof. So what that means is it is a rule that we don't have to justify. We know it's a fact and we don't have to explain it. It just is what it is. And postulates are things that are going to come up a lot, especially when we get to more of our vocab heavy sections in this chapter. Our next vocab word is distance. And this distance shouldn't be a concept that's familiar to you guys, just like distance from school to your house, except in geometry, we're going to be talking about distance between points, especially on a coordinate plane. So our fancy definition for distance is the absolute value of the difference of the coordinates of 2 points A and B. So you find the difference between A and B, and then it always has to be absolute value because distance is always positive, right? If you end up with a distance being -2, that wouldn't make sense because you can't travel negative distance. And then we do have a certain notation for distance. So remember, we've learned a lot of labeling so far. I'm going to do some examples up at the top. So remember, we have learned that a line, right? You have 2 letters like A, B with a double-sided arrow above. You can have a segment, that's your 2 letters with just a bar, and you can have a ray with your one-sided arrow. When we talk distance, we write it as just the 2 letters with no symbol up above it. So if you see 2 letters paired together, this is a distance, which keep in mind that means it's a number, right? It is a numerical value or a number. It's representing it. Think of it almost like a variable. Congruent segments. Congruent is a super important vocab word. We talk about things being congruent all year long. Congruent is our fancy geometry word for equivalent or the same. So our definition here, congruent segments, those are line segments that have the same measure. Or in other words, the same distance, right? The distance between 2 points is kind of like its measure, it's its length. And we have a special symbol for congruent. It is a equal sign with a little squiggly line above it. So to kind of talk about our notation here and what it really means to be congruent, we're going to look at these 2 segments here on the left. We have segment AB. So remember, we would call that AB with our little segment bar above it, and then segment CD with our little segment bar above it. Let's say I told you that the measure of AB was, I don't know, 5 units, whatever that is, 5 miles, 5 inches, 5 feet. Okay. Using our notation that we learned up at the top, that means the numerical value of segment AB is 5, right? That's its measure. So I could say the measure of AB equals 5, and that's how you would read that. The measure of AB equals 5. Well, let's say the measure of CD was also 5, whatever it is, inches, feet, yards, whatever. Well, then I could say the measure of CD is also 5. Well, these 2 things have the same measure, right? The measure of AB equals the measure of CD because they're both 5, right? 5 equals 5. So the measure of AB equals the measure of CD. Now, what that means, since they have the same measure, that means they're congruent. And how we would write that is segment AB, and you'd put your little bar above it, is congruent to segment CD. So these two things here are often mistaken, right? So saying two segments are congruent is what that looks like. If you want to say their measures are equal or they have the same numerical value, that's what that looks like. They mean similar things, but they're slightly different, and the notation is a little bit different. This one, this is a number, right? That's its value. Where this, that's its name. Okay? So this is a label or a name, this is a value. All right. Segment addition postulate. This is where we kind of get to solve some problems. So what the segment addition postulate says is if point B is between points A and C, which if you look at this picture, it is, point B is sitting between A and C on this line, then the measure of AB plus the measure of BC equals the measure of AC. In other words, you have this big segment here, and it's being broken down into smaller parts. You have a little part here from A to B. You have another little part here from B to C. And then you also have the whole thing from A to C. So what this theorem tells you is if you take this part plus this part, it's going to give you the whole measurement. So a way that I like to refer to this is that part plus part equals whole. And you'll hear me say that a lot. Part plus part equals whole. So think of it like if you were traveling somewhere and taking a pit stop, right? Maybe the first day you go 50 miles and the second day you go 100 miles. You want a total of 150 miles, right? You take your parts, add it up, make the whole thing. So let's look at an example here. Example 1 says find the measure of km. So again, remember this doesn't have a bar above it. So when you see the letters km like that, this is asking for a measure. It wants its value. So look at your picture then. This is the time where, again, just like in our last set of notes, we had to interpret our pictures. That's going to come up again and again. Look at your picture here. Km is the whole thing. So it wants you to find the measure of the whole thing. Well, it's being split up into smaller parts. From K to L is 14, and from L to M is 3. So to find the entire thing, add them up. Your total measure, km, would be your one part, 14, plus your other part, 3, which is going to give you a total of 17. Then for number 2, it says find the measure of ST. ST is this little chunk here. So again, look at your labeling. It's telling you from S to U is 22. So that's the whole thing. And from T to U, this little chunk here is 4. You got to find this missing piece. So where in 1 you added, in 2 you're going to have to subtract because you already have the whole. It's kind of like working backwards. So to find the measure of ST, you'll have to do 22, which is the whole thing, minus the part you already have. So you should get 18. So in number 3, it says find the measure of ST if segment RS is congruent to segment TU. So it's telling you that this little part here, if you look at your picture, is 6. The whole thing from R to U is 24. It wants you to find ST. So this little missing chunk is what we need to find. But your directions say that segment RS is congruent to segment TU. Okay, so what does that mean? Well, if segment RS is 6, then this means that segment TU is also 6. And this actually reminds me, there's some labeling we need to talk about that I forgot to talk about up above. So if you go back up here to our picture for congruent segments, there's some labeling that will happen in your picture when things are congruent. If two segments are congruent, you'll often see them marked with little dashes. So one little dash in each means they're congruent, two little dashes in each means they're congruent, three little dashes, and so on. Okay, so those are congruent. So if you look at number 3, RS is congruent to TU, so those are both 6. We have to find that missing part there. So again, we have the whole thing. We have the little chunks on either side, so you're going to need to subtract. So the measure of ST equals 24 minus what you have so far, which is 6 plus 6. And you can do it separately if you want. Like if you know 6 plus 6 is 12, so you just automatically go to 24 minus 12, that's fine. So you'll have 24 minus 12, which equals 12. And then last example for this part of the video. In the diagram, segment QU is 120, segment SU is 50, segment RS equals the measure of segment ST equals the measure of segment TU. Find the indicated values. Now, there's a lot of information happening here, and none of it is labeled in your picture. So something I strongly suggest is to always label your picture if you're given information. That way you're not always going back and forth. Here is your segment. You were given that QU is 120, so let's label that. That is the entire thing here is 120. And then it tells you SU is 50. So that is this little part here is 50. And then the measure of RS equals the measure of ST equals the measure of TU. If those have the same measurements, then they're going to be congruent. So I'm going to put my little tick marks in this. Now, where you go from here is kind of up to you. The first thing that sticks out to me is that the whole thing is 120, and then one part's 50, which means you can easily subtract to get the other part. So that means from Q to S, if you do 120 minus 50, is going to be 70. Then the next thing I notice is that the segment SU is 50, but that either part of it is congruent. Well, if you have 50 and it's being split up congruently or equally, that means that's like in half. So that means each little part here, oh no. Okay, we're back. That means each little part here is going to be 25. And if those are 25, RS is also 25. And now I actually have everything labeled. So let's go back and check this out. RS, we already have it labeled. It was 25. Measure of QR, well, that is this part here. I guess I forgot to find that one. But that's not too bad because I know the whole thing is 70. I know I have 25 so far, so subtract that out. You should get 45. And then RT, from R to T is 25 plus 25, which would give you a total of 50. Okay, so that's just one strategy. You can go by piece if you want. It's up to you. In the next video, we're going to talk midpoints and segment bisectors.